Hi, this is Maggie from Design Code Debug Repeat. If you're a beginning programmer, a beginning game programmer, a beginning data analyst, a programming teacher, or if you just find this content interesting, please consider subscribing to the channel. I'll be posting lessons, tips, and other cool programming stuff regularly. So as you may or may not know, I am a college professor and I do, unfortunately, sometimes get code submitted to me that was plagiarized from the internet. When that happens, I usually go look for that code, and I usually find it. And if you're wondering how I find it, well, probably the same way the person who plagiarized it found it. In a recent search, I came across this page on Stack Overflow, which I thought was, well, kind of funny. It's a question, are while true loops so bad? And so I decided to answer the question, and in the process, yes, I might make fun of some of the answers here a little bit, because some of these folks should know better based on their profiles. But I'm also going to give you concrete suggestions for how to take a while true loop and write a good, readable, debuggable loop. So, beginning with the question, are while true loops so bad? The poster says they're a programmer who returned to college and wrote an input validation loop like the pseudocode loop they posted here, and they lost points for it. Now, I understand if we're in a supportive community, we're going to try to support our friend here who lost points. I get it. But it doesn't support somebody in the long run if you're reinforcing a bad practice. And I think, based on some of these comments, there's a little bit of resentment toward college professors. For example, this person wrote, teachers are allergic to GoTo because they heard somewhere it's really bad. Which proves this person never tried to talk to a teacher at all about the subject, because I don't know a faculty member who won't argue from evidence like it's life or death about their subject area of expertise. But this comment is 103 as a usefulness score, which tells me there's maybe some general resentment toward faculty, and maybe that's on faculty. Maybe faculty haven't taught why we don't use while true loops clearly enough. Loops are difficult to learn, so maybe a while true loop is the easiest loop for a beginning programmer to write, and so they resent a faculty member telling them they can't do the one thing they can manage to do, and they don't understand the reasons. What I don't understand is why an experienced programmer would write a while true loop. I don't understand how that comes into existence. There's some implication in this thread that maybe while true loops shouldn't be written by beginners, but once you know what you're doing, it's okay. How is that exactly? If you know what you're doing, then you know when your loop is entered. You know that your code should be readable to other programmers and less prone to error, so how on earth do you end up writing this lazy, terrible loop? The only argument that you have that your loop is correct is one of faith, not evidence. Now, down near the bottom, with helpfulness scores around 12, there are some great responses. This one says, you need to take into consideration other developers when coding, even in school. Your fellow developers should be able to see the exit clause for your loop at the loop declaration. You didn't do that. You hid the exit clause in the middle of the loop, making more work for someone else who comes along and tries to understand your code. This is the same reason that things like break are avoided. Great answer, Rfeek. You're in agreement with Guido van Rossum, the creator of the Python language, who said that code is read more than it's written. Rfeek continues on to say, that being said, you'll still see things like this in a lot of code out there in the real world. Which, by the way, is sad and true, and how I usually know the code that was submitted to me has come from the internet. My favorite response is the one below this one, and starts, it's your gun, your bullet, and your foot. This whole thread is definitely worth a read through. If I've missed something here, please tell me in the comments. Okay, that's the end of the rant portion, more or less. Let's move on to remedies. If you're a beginning programmer, or you're not a beginner, but some lazy or logic-challenged programmer convinced you that while true was perfectly fine, and now you've formed the habit, how do you write better code? Okay, So what I've done is borrowed some of the loops from the Stack Overflow thread, which are Java pseudocode, and I've created Java and Python versions of them. And we're going to start with the pseudocode from the original question. Now, Python doesn't have a do-while construct, so I'm going to use a regular while construct. So what I'll do first is just fill this pseudocode in with actual code. And literally these are my first while true loops. So I will also test them. So let's look at this. First, you might have noticed that the original pseudocode didn't work. And I don't know if that's how the actual code was written, but in the pseudocode he had an otherwise get the input again. And when you're getting the input that time, you're never testing it because we're just heading right back into the loop regardless, because our loop entry condition is while true. We don't have the original code, but the person writing code like this is presumably able to write a logical condition for when the input is valid, because that's after the if statement when we break out of the loop. So if they can write that, they can restructure this to write a loop with a logical condition in the loop header. What they might have trouble with is complementing the condition. The complement of a condition is the logical opposite. When a condition is true, its complement evaluates to false and vice versa. I have a video that covers complements in more detail, and I'll link it in here. But let's talk about complementing this condition, which may or may not look anything like what the original problem was because we don't have it. This is a compound condition with an AND, a check for a value within a range. You complement this sort of expression with De Morgan's theorem. Complement the expression on each side of the AND then change the AND to an OR. Or if you have an OR, complement each side and change the OR to an AND. So the complement of greater than or equal to is less than, and the complement of less than or equal to is greater than. The condition for entering an input validation loop is when we have bad input. So while input value is less than 1 or input value is greater than 10, you can draw that on a number line to see how it's the complement. And a pattern that you use with a while loop when validating input is to first have a priming read. So we'll read the input, and then we'll write a loop that will be entered if that input is bad, and the user will be trapped here as long as they give bad input. We might even put some code in here to let them know why they're being asked for input again, like a print statement that says the number must be between 1 and 10. Now, once we're past the loop, we can write an assert statement. What do we know when we're past the loop? We know the input is valid. So again, the complement of that loop entry condition, which was the condition for invalid input. So that original condition, actually, we'll write assert 1 is less than or equal to input value, and input value is less than or equal to 10. Now, suppose validating the input is much more complicated than this. Maybe we have a whitelist of valid inputs and we can't write it in a simple expression. Then you write an input validation function, and we'll do that for one of the other examples. Let's move over to the Java code, which is a do-while loop. A do-while loop is actually a great construct for obtaining and validating input, just not a do-while true with a break in the middle. So for this, we should obtain the input in the loop, and then we can simply write the condition on the while. And again, the condition will be the condition for invalid input input value less than 1, or input value greater than 10. And that's it. Now, if we don't want to keep slamming the user with the input statement without telling them why they can't move on, we might want to include a message inside the loop that their input is invalid. Because we're getting our input for the first time in the loop, we can't assume that they've already entered invalid input, and we need to test that after they enter their input. So, inside the loop, if input value is less than 1 or input value is greater than 10, maybe system out println the number must be between 1 and 10. You can, of course, write a while loop with a priming read in Java just as we did in Python, but Python doesn't have a do-while, so I wanted to stick with this structure and illustrate how we can still write a better loop that isn't a while true. Why is this better? It's readable, first of all. After the keyword while, you should see exactly when the loop is entered, and there should be no nasty surprises buried in the loop that mean this expression is a lie. That sort of surprise can make code very hard to debug and can lead to errors, including infinite loops and security errors. If a person insists on writing a while true loop, ask them to write a loop invariant, which is a logical expression that is true every time the loop is entered and is used to prove a loop's correctness. If they can, then they should have written their loop properly in the first place. And if they can't, then the reason they're writing while true loops is because they don't know logic or when their loop is actually executing, and I'd be a little worried about the quality of their code. Now, this other example, let me tell you why I called it a straw man argument, and maybe it's a false dichotomy, call it whichever makes more sense to you. There are a few comments on this thread that imply that the only alternative to a while true is a flag, a Boolean variable at the top of the loop that you set to false somewhere in the loop. I agree that a flag-controlled loop isn't much better than a while true loop, although at least if the flag is well named, it offers more information than while true. But it's a false dichotomy because the third option is just to write a decent loop with a logical loop entry condition to begin with. And this pseudocode example that was provided and that I've copied here doesn't actually make any sense to me. I've thought about it some. I think this code is poorly structured to begin with because the person has mixed other code with the input validation code. I think this should probably be an input validation loop embedded within another loop. I don't know, of course, because it's pseudocode and this person doesn't offer any context. So what I'm going to write here is a loop that obtains 3 inputs from the user and will keep executing as long as they're all positive. So along the lines of, we're going to keep running as long as the user is entering positive numbers. So I'm going to take a moment and write a while true version of that, and then a version that uses an input validation method in Java as promised. I'll write the Python version and upload it with the Java code, but I'm not going to write it now because this video is already long enough. Okay, we have an input validation method called still running. And with this example, we're going to have the loop running as long as the user enters 3 positive numbers each time through. Now in the while true version, we break out if any of the values are less than or equal to 0. If we make it past the break, then this print statement executes, congratulating the user. Now imagine if this were a longer loop and a programmer reading it hadn't noticed the break. They're probably debugging it because it's probably buggy because it was written by a novice or a lazy programmer who doesn't really know when it's executing. And they're looking at some code at the bottom and scratching their head because they can see lines that they believe are executing, not realizing that there's one or more break statements somewhere up above in the murky depths of the loop body, prematurely exiting from the loop. If you look at this quickly, you might not realize that this last line of the loop doesn't always execute. I'm just trying to convey why aborting out of the middle of a structured programming structure makes reading and debugging the code so much harder. Now, in the non-while true version, we have a while still running input value 2, input value 3. And this is my alternative to a flag. Now, why is this better than a flag? This is better than a flag because we can see all of the variables that could potentially impact whether we enter the loop or not. And if the method is named in a meaningful way, it should be pretty clear what it does. In this case, I chose still running because it was pretty close to the original pseudocode flag name. So instead of potentially 3 or more different assignment statements scattered throughout the loop that might change the flag, we can look at the method to see exactly how these variables impact whether we enter this loop. Inside the loop, rather than write the if condition that breaks the loop or sets the flag depending on the version, and then on the else printing the statement, we write the complementary condition and print the statement. This is preferable because it's much easier to understand a positive logical condition, the condition under which something will happen, than to mentally complement and try to figure out when it's executing as with an else. And it's absolutely preferable to a line of code that will only execute if the loop hasn't broken above it. So this code is superior to the suggested version with a flag, and it's definitely superior to a while true. Now, this may not be a good example. I don't know. The examples given in the answers to the question were pseudocode, and the original pseudocode of this seemed badly structured to me in other ways. If you enjoyed this video, please consider giving it a thumbs up. If you think I'm absolutely wrong, or you hated this video, or if you disagree with me, if you have a metric other than readability, debuggability, correctness, or security that you want to suggest as a superior metric, or if you think there's something in this thread I missed that's worth addressing, please comment below. I welcome debate. If you enjoy this sort of content, please consider subscribing to the channel. I'll be posting tutorials, examples, and other fun stuff in a variety of programming languages every week. Take care.